Hello everyone. Today in this video I'll be discussing about a great IT tool known as Ansible. I am sure many of you might already be knowing about Ansible, but for those of you who have a little or no idea about this tool, you would find this video to be very useful. This video is really an introduction to Ansible, and I'm sure after watching this video you would be able to understand the basics of Ansible correctly and be inclined to use it. Before I deep dive into Ansible, let us have a look at very familiar situation which most of the IT server administrators often face. In this case, it's Bob. So Bob here is a server administrator who really loves his job. He manages some Linux and Windows-based servers, which you can also see on the screen. Now, it's a beautiful Friday evening, and as Bob is planning to leave his office, his boss comes and says, "Hey Bob, can you do a quick task for me? Please install the latest software on all the machines and then reboot them. And once you're done with the job, just go home and enjoy your weekend." Pretty typical of the boss to say like that, right? But for Bob here, the conventional approach to handle this task would be to take SSH of all the Linux machines, remote desktop of all the Windows machines, install the software manually in all of them, reboot the machines, and go home and enjoy his weekend. Looks pretty easy, right? But what if there were hundreds of such servers? Now, Bob can be really smart about it as well. He can write some beautiful scripts to automate the tasks. But the catch here is that Bob would have to know both Python and PowerShell as he has both the flavor of machines with him, Linux and Windows. But if Bob is unlucky and doesn't know scripting, then Bob would have a hard time. He would have to do the entire task manually, and not only the Friday evening, Bob's entire weekend would be spent in office, and he would hate his job. But now, do we really want Bob to hate his job? No. So here comes Ansible to save Bob. Bob just needs to install Ansible on one of his management machines, which is also known as the controller node. Now, it's the controller node which will automatically install software in all the machines and reboot them. All of this happens very quickly, and Bob gets to go home and enjoy his Friday evening. So now, I think you must have got a fair idea about Ansible and what it does. Yes, it's an open source automation platform. Ansible is used to automate the repetitive tasks. For example, the tasks which we discussed here, such as installation of software in machines, which happens quite frequently and is really time consuming as well. Additionally, Ansible is used to manage the IT infrastructure and also to streamline the DevOps processes. I'll be discussing both these topics later in my video as well. Now, one of the most beautiful things about Ansible, which I love, is that we do not need to have some major scripting skills. It is because here we use YAML-based scripts which are known as playbooks, and these playbooks are very easy to understand and write as well. So if Bob doesn't know PowerShell or Python, it is not a worry at all. The YAML-based Ansible playbook script takes care of all of that. Before I move on to the architecture and working of Ansible, I think it's important to give credit to Mr. Michael D. Hahn for developing such a great and powerful tool, Ansible. And now, Ansible is being maintained by the Red Hat team. Now that we have got a fair idea about Ansible, let us come to its architecture. So, we have a control node wherein Ansible is installed, and the machines wherein we want to run the automation tasks are called the managed nodes. For Ansible to do its magic in the managed nodes, the control node should of course have the network reachability to all the managed nodes. Also, the control node has to be provided with the access credentials of the managed nodes so that the control node can successfully establish connections with the managed nodes and instruct them to execute the desired tasks. To connect with Linux hosts, Ansible uses SSH protocol, and to connect with Windows, WinRM or Windows Remote Management Protocol is used. Once we have this setup in place, now we can move on to the working of Ansible. Now let's imagine that our control node has access to all the managed hosts. But before we move ahead, we need to tell Ansible precisely in which of the managed nodes we want to execute the tasks. So we build a file known as the inventory. In inventory, we simply need to put IP addresses or host names of our managed nodes on which we want to execute our tasks. Let us say presently we have 5 managed nodes which are named as server 1 to server 5. So In our inventory, we can simply enter the host names as shown, server 1, 2, 3, 4, and 5. However, Ansible also allows us to group the managed nodes as we like. For example, we can group our managed nodes as Linux hosts comprising of server 1, 2, and 3, and Windows hosts comprising of server 4 and 5. Now that we have told Ansible about our target machines through inventory file, we can move ahead and focus on the modules. When we install Ansible in a control node, the installer installs something known as the modules. Now, modules I feel are the most important part of Ansible. Why? This is because module contains the scripts which perform our desired tasks on the managed nodes. So during installation, Ansible installs several inbuilt modules for various platforms. The availability of thousands of these modules is what makes Ansible so powerful. For example, we have modules to perform tasks in Windows machines, modules for Linux machines, and for several other platforms including firewalls, routers, etc. Here, I am taking an example of Cisco's ASA firewall. Now going further, we have few of the Windows built-in modules, which are win_user, which is used to manage users in a Windows machine, win_shell to execute PowerShell commands, and win_robocopy to copy data in a Windows environment. There are several other Windows modules as well, and all these modules are written in PowerShell because PowerShell is native to the Windows platform. Similarly for Linux, we have user, shell, and copy modules, which do the similar tasks in a Linux environment, and all these modules have been written in Python. Regarding Cisco's ASA firewall, I am taking example of 3 inbuilt modules. ASA_ACL to configure the access control lists, ASA_command to pass the necessary commands, and ASA_config to configure the firewall. Now, all these modules are written in a language which the Cisco ASA firewall understands. But hey, we don't have to worry about the language in which these modules are written. For us, the most important thing is to know which modules are available for our disposal by Ansible so that we can use them and exploit them. Now let's get back to the original task wherein Bob had to install the software on all the servers and then to reboot them. So if we actually list out the steps involved in this task, this breakdowns into multiple subtasks as follows. First is to copy the new software installer from a central server to all the managed hosts. Then install the software on all the managed hosts. Delete the copied installer and finally reboot the machines. So Ansible has inbuilt modules for each of these subtasks. Our job here is to identify the correct module, list them stepwise in a YAML file, which we will be calling as our playbook. Once our playbook with correct modules is ready, we can tell Ansible to execute the playbook and carry out the tasks on the managed hosts. So here is a sample playbook for Bob's task. This is a simple YAML file wherein we are writing content as per a predefined syntax with a proper indentation. Notice that we have defined hosts as Linux group, which consists of servers 1, 2, and 3. Through this, we are telling Ansible that we want to run our defined modules on these Linux server groups. So the first module which we are using is the copy module, which is used to copy the installer file from the remote location to our Linux servers. Then the second module is the yum module through which we are installing the software package onto the Linux servers. And the third one is the Linux file module through which we will be deleting the installer once our installation has been done on all the Linux servers. Finally, we'll be rebooting the server through the Linux reboot module. Now, the collection of all the server groups and the modules is known as a play. I hope you remember that Bob also has some Windows hosts, and the modules for Windows machines are different. Therefore, we need to write a play for the Windows machines as well. So first we have defined the Windows hosts, which consists of servers 4 and 5. And then we have used the Windows copy module. This module is not similar to the copy module which we use for the Linux. This is win_copy module. So this module is specifically meant for the Windows machines. It is doing the same job. It is copying the installer from the remote location to our Windows machines. Then is the win_package module through which we'll be installing the software. And the last module which we'll be using is win_file through which we'll be deleting the installer from all the Windows machines. Finally, we'll be rebooting the Windows machines through win_reboot module. Now this is one more play which we have. So finally, our playbook looks like this. This consists of two plays, one play for the Linux hosts and the second play is for the Windows hosts. And the collection of both these plays is the playbook which we have. Let's call this playbook install software.yaml. So now that we have our playbook in our hands, we can tell Ansible to execute the desired tasks on the destination hosts or our managed hosts. If I sum up everything, it looks something like this. Bob has a playbook which has been loaded with the correct modules, and now Bob is ready to fire this playbook using Ansible on the inventory, wherein he has defined his targeted managed nodes, which are servers 1, 2, 3, 4, and 5. So the command for that is Ansible playbook followed by the name of playbook. So in our case, the name of our playbook is installed software.yaml. So Bob will fire a command Ansible playbook install software.yaml. That's it. And once he does that, Ansible's controller node will do its magic. It will establish connection with the first server and do all the following tasks. It will copy the installer, it will install the software, delete the installer, and then reboot the machine. And once it has been done with server 1, it will do the same to rest of the servers. Advantages of Ansible. First one is pretty simple. It is very easy to use. We don't have to write any complex codes and all. It is agentless. It means we do not need to install any agent in any of the managed nodes. Ansible just contacts all the managed nodes and executes its tasks in all the managed nodes. By idempotent, I mean that if we run a same playbook multiple times on the managed node, it will always result in the same state of the system. So you don't have to worry about whatever happens if we run a same playbook multiple times on a managed host. It will always result in the same state. There will be no change in the state of the managed host. Cross-platform thing is a very powerful feature of Ansible. Here in our use case, we just talked about two variants like Linux and Windows, but literally Ansible can be used against multiple ranges of platforms. I don't know exactly how much, but it can be used against a lot more. Ansible is highly extensible. It has a wide range of plugins and modules available to extend its functionality. So that we'll be discussing later on in the video as well. All the playbooks are usable. You can share your playbooks with everyone, and it will give you a good collaboration feature. It is scalable, which means that Ansible can be used to manage large-scale infrastructure, which also supports parallel execution and distributed deployments. And last but not the least, Ansible is pretty secure as it comes with strong security features, including support for encrypted variables, secure key management, and much more. So before I sum up this video, I will like to cover a few more important concepts about Ansible. So earlier I spoke about Ansible being secure. So the question which can come to our mind is, how does Ansible handle all the sensitive data? By sensitive data, I mean the passwords or the private keys which are used to access the managed hosts or any APIs keys. Well, the answer for that is Ansible Vault. So we define a text document called as Ansible Vault, and we define all the sensitive data in there. For example, our passwords and everything. Then we have to choose a password for this Ansible Vault file as well. The vault encrypts the entire sensitive data using the AES algorithm. So whenever we execute our playbook and any sensitive information is required, for example, password of a managed host, the playbook prompts us for the Ansible Vault's password. We just enter the Ansible Vault's password. The Ansible retrieves the required information from the Ansible Vault, and the playbook execution continues. It is pretty cool, right? Now, the next question which can come to our minds is, what if the playbook is too large and complex? For this, Ansible provides us with Ansible Roles. Well, roles provide a way to break down complex tasks into smaller and more manageable components so that it is easier for us to maintain and reuse the code across different projects. Roles can be organized into a directory structure that makes it easy to share and reuse roles across different projects and teams. Let me give you an example of a very simple rule to install Tomcat in a managed host. So the typical directory structure is like this. The top level directory is called, for example, my role. It can be called anything. Within this directory, we create subdirectories such as tasks, files, templates, vars, defaults, meta, etc. These directories in turn contains the files as per their roles. For example, this main.yaml is a main playbook. The main.yaml file in the vars directory contains details such as Tomcat version to be installed, port details, installation path, etc. Any other required default variables are defined in here. The Tomcat configuration parameters are defined in these Jinja 2 templates, and any other required parameters are defined in here. So this distribution makes the entire playbook much cleaner and simple. And so roles provide us with the following advantages, which are pretty straightforward to understand. Now, the next question is everything CLI based in Ansible? What if my team is not comfortable with writing playbooks, or if there are playbooks available, they are not comfortable with executing those playbooks from the CLI? Is there anything which can help us with Ansible? Yes, for that, Ansible provisions something which is known as the Ansible Tower. It's a web-based dashboard which provides several advantages. It's an enterprise level tool, and the licenses have to be purchased from the Red Hat team. You can check the pricing details on the official Ansible website. These are few advantages which the Ansible Tower provides. First is, as we discussed, it's a web-based dashboard. It provides us with role-based access control. So if we have a large team, we can give them role-based access on the playbooks. For job scheduling, I mean that we can schedule Ansible playbooks to execute the tasks at the desired time intervals. If we have a big inventory, like we have hundreds of servers and we want to manage them and segregate the inventory, so we can use Ansible Tower's front end to manage inventory into different groups. With REST APIs, you can integrate Ansible with other DevOps tools, and notifications is one of the beautiful feature which Ansible Tower provides. For example, you can schedule a playbook, and if the execution fails or if it succeeds, Ansible Tower will give you a notification for both the cases. Here is a screenshot of Ansible Tower. We have talked about various inbuilt modules and all. Now the question is, can I download additional Ansible content, and can I share my content with others? For this, we have something known as Ansible collections. Well, it's a packaging format from Ansible that allows us to bundle our content such as modules, plugins, and playbooks into single shareable unit, which is known as a collection. So collections can be uploaded on a private or public repository. We can then download these collections and then use them the same way we use the inbuilt modules. The concept is pretty similar to the Docker registries and pushing and pulling of images from the Docker registries. So this makes sharing of Ansible content pretty easy, in fact. Now, as we are nearing the end of this video, I'm going to tell you why learning Ansible is beneficial. It is because Ansible is being used everywhere. And by everywhere, I mean all major IT cloud providers are using Ansible. They're supporting Ansible. It's a key tool for the DevOps teams. Infrastructure as a tool is a growing trend in IT, and Ansible is a key tool in there as well. Ansible is being used extensively to automate the process of deploying and managing machine learning models, and it is well suited for managing containerized environments as well. Well, I personally think that Ansible has a very bright future. In fact, it's going to stay, and it's going to get more and more powerful in future. So if we learn Ansible, it will be very, very beneficial to us. Well, I think I've covered most of the basic concepts in here. I'm sure you would have understood the basics of Ansible. If you have any related questions, just put those in the comments and I will try to answer them. I am also planning to do an elaborate series on Ansible, right from installation to playbook execution and all. So if you found this video useful, please do like, share, and follow me. This is my first video and I would love to create more such content in future as well. Your support would definitely encourage me. Thank you. Happy learning.